So triangle congruence proofs, when you ask somebody who is older, who's taken geometry, whenever they talk about geometry, they say, oh, I fill in the blank proofs. Either I hated proofs or I loved proofs. And so I've got 3 proofs we're going to go through here, and hopefully this helps you get a little bit better at proofs. They're kind of tricky, but you know what? They're really not that bad. All you're doing is you're just saying how you know what you know. And that's something that we'll get really good at. So, a few things first. We've got this thing, CPCTC. This stands for corresponding parts to congruent triangles are congruent. So if we have congruent triangles, the corresponding parts, or the parts that match up, those have to be congruent. And if you think about it, if 2 things are the same, then the parts that match up also have to be the same. So that's all this is saying. And a real brief story about this, I was in Vancouver, British Columbia one time, and I was driving down the road, and I saw the coolest license plate ever. It was CPCTC. Obviously a very cool guy or gal. So down here, what this is saying is if triangle ABC is congruent to EDF, then what sides do you know on triangle DEF? So ABC is congruent to EDF, so if AB is 45, then that means DE would also be 45. And same thing, if BC is 53, then DF would also be 53. Okay, so let's get into a couple of proofs here. So I have a picture here, some given stuff, and then it asks you to prove this stuff. So here's what's given. It says given PR is congruent to SR. So what I like to do is I kind of like to mark them. PR is congruent to SR. Great. And then QR is congruent to TR. So I'm going to mark that differently because those are not necessarily the same as the other lines. So this is what's given to you, and it's asking you to prove that PQ is congruent to ST. Okay, so here's how we're going to do this. The first thing you do is we set up like a T-chart. It's statements and reasons, and we're just going to state what we know. So the first statement is PR is congruent to SR, and QR is congruent to TR. And I forgot to put my little lines above there, so we'll do that. There we go. And that reason was given. That's something that was just given to you. So we have that marked on the picture. So now we need to start saying, well, what else do we know about these 2 shapes? And one of the things I noticed right away is that this angle is going to be the same as this angle down here. And so I stated that. Angle PRQ is congruent to angle SRT. And let's write that in there. Angle PRQ is congruent to angle SRT. And how do we know that? We've learned that, but what's the reason? The reason is these are vertical angles. And so I know that because I know they're vertical angles. So all we say is the vertical angles theorem. It's that simple. So now I notice that I have 2 sides on this bottom triangle and the angle in between those 2 sides. And on the top triangle, I have the same thing. I've got 2 sides and the angle in between them. So that means that the top triangle and the bottom triangle have to be congruent because of side, angle, side. So my statement is that triangle PRQ is congruent to triangle SRT, and my reason is side, angle, side. So this statement here and reason tell me that these 2 triangles are the same. They're congruent. So if they are congruent, that means that this side up here has to be the same as this side down here because these 2 triangles are the same. So if these 2 triangles are the same, then all the parts that match up have to be the same. So same thing here. This angle would have to be the same as this angle. But that's not what they're asking us to prove. They're asking us to prove is PQ congruent to ST. And the answer is absolutely, because the 2 triangles are congruent. And that's what this means, CPCTC. That means that the corresponding parts of congruent triangles have to be congruent. Okay, So that's kind of an introductory type problem. The next two are a little bit more advanced, and hopefully I can help this make a little bit of sense here. So let's look at the next one. This one, it says given ABCDE is a regular pentagon. And it wants you to prove that AD is congruent to CE. Okay, so this one's a little bit more complicated. And then I reminded you here that a regular pentagon, regular, means that all of the sides are congruent and all of the angles are congruent. So that means angles A, B, C, D, and E, if these lines weren't in there, those would all be the same degrees, and all the sides on the outside are the same. So we start with what's given, and I have that written in here. ABCDE is a regular pentagon. That's what was given to us, and so we'll write given. Okay, so from there, what I'm going to do is I want to make this a little bit less messy, because we end up having, we want to prove that these two triangles in here are congruent, so ADE and CED. But it gets kind of messy with the overlap, so I'm going to pull these out. So I've got this triangle, this is AED, and then I've got the other triangle, this one's CED. So let's label these while we pull them out. So it'd be AED, and this one is CED. Okay, so let's start marking these up and saying what stuff is the same. So a couple things. If this is a regular pentagon, then that means that AE has to be the same as CD, because all the sides on a regular pentagon are the same. And then likewise, angle E has to be the same as angle D, because those are part of the overall regular pentagon. So those angles are also the same. Okay, so that's my statement. Side AE is congruent to CD, and then angle AED is congruent to angle CDE. And my reason is because it's a regular polygon. In this case, it's a pentagon, but a regular polygon means all the sides are the same and all the angles are the same. Okay, and the other thing I notice is on both triangles, they both have side ED. So they're not necessarily in the same order, because one triangle, E is the obtuse angle and D is the acute angle, and on the other side, D is the obtuse and E is the acute. So I would say ED is congruent to DE, and I said them in that order because E is obtuse, D is acute, and here D is obtuse, E is acute, so ED is congruent to DE. So I'd write it like this. And that reason is called the symmetric property. So there's another one you might learn in geometry class called the reflexive property. And that would be if they're overlapping and you'd write them in the same order. So if it was like obtuse to acute is the same as obtuse to acute, but in this case, they're kind of flipped. So reflexive is if it's ED is congruent to ED. Symmetric is this case. Okay, so let's mark that on our pictures. We know that ED is congruent to DE. So we have, I look at these two triangles, I see a side, an angle, and a side, and the angle is right in between the two sides. So I notice that this red triangle has to be the same as this blue triangle because they both have the two sides and the angle in between them, so side, angle, side. So my statement is triangle, oops, I don't think these triangles are shown up here. Of course not. We'll just go the old-fashioned way. Okay, so triangle AED is congruent to triangle CDE, and that we said was side, angle, side. So this was the triangle congruence property that we learned, side, angle, side. Okay, so if these two triangles are the same, the red triangle and the blue triangle are the same, then that means that this side out here, AD, is going to be the same as this side out here, EC. And we know that because these two triangles are congruent, So that means all the sides are also congruent. So we'll kind of scroll down here, and my statement is now what we want to prove. We want to get to the point where it says AD is congruent to CE. That's what it's asking us to prove. And we know that because if these two triangles are congruent, then that means the sides are congruent. And that's what CPCTC stands for. Okay, one more. This video is getting a little long, but we'll do one more quick one, hopefully. This one says, given ABCD is a parallelogram, prove triangle ABC is congruent to triangle CDA. Okay, so this is a parallelogram. That's my given. So that means that AB is parallel to DC. That's what a parallelogram is. So that's just the definition of a parallelogram. So I'll write that in up here. Okay, so from there, I now know that this angle is the same as this angle, and I also know that this angle is the same as this angle, because this is a transversal cutting two parallel lines, and that's the alternate interior angles theorem. So I know that these two angles are the same because of alternate interior angles theorem, and same thing with these two angles. So we've got two angles on each triangle, so I'm looking at one triangle here and one triangle here. Okay, I also notice that both triangles, oops, didn't want that, have an overlapping line. So that line is the same for both triangles. And so the way I'd write that is AC is congruent to CA. And I wanted to write that not AC is congruent to AC because on this triangle down here, A is the bigger angle and C is the smaller angle. And here C is the bigger angle and A is the smaller angle. So I want to write them in that order. And that, once again, is the symmetric property. Okay, so now I'm looking at these two triangles. I see an angle, another angle, and the side in between them. Then over here on this triangle, I see an angle, another angle, and the side in between them. So these two triangles are congruent. And I know they're congruent because of angle, side angle. So that's what they asked us to prove, was triangle ABC is congruent to triangle CDA. And notice the order of the letters again. ABC starts at the double tick mark, goes to the unmarked angle, and then to the single tick mark. So that would be CDA on the other triangle. Okay, so there's a few examples of proofs. That obviously doesn't explain every proof that you'll ever come across, but hopefully this helps you understand the structure of how to write a proof.